Good evening. You've heard a lot about creativity today, and so I wanted to take a few moments to give you some context around the idea of creativity as it applies to technology. Now, if you pay any attention to what's going on in the world, you probably have heard about two huge issues: climate and artificial intelligence. In fact, part of the conversation is around whether AI can save us from the climate disaster. But the truth is, the AI revolution that we are having now has come at a cost. And that cost relates to the climate. AI, in fact, can do more damage than good, which is a great challenge. So tonight, I'd like to give you an example of how we're using creative solutions to try and solve this challenge while creating a new, clean way of computing. The cost of AI comes from the enormous computational power it requires. AI is very hungry in terms of energy requirements and its footprint. To fuel a truly creative economy without causing undue damage to our planet, we have to solve the challenge of increasing computational power with sustainable energy. To show you just how bad things are, let's take a look at Bitcoin, probably one of the least useful computational activities, and its global footprint. Bitcoin mining has the same carbon footprint as the whole country of Nigeria. It consumes as much energy as the total consumption in Poland at this time. This is a quickly worsening picture, though, and we're not really addressing it yet. In fact, right now, we're just hoping for the best. The amount of energy we use for computing, just for computing, is increasing. In fact, at some point in the near future, all of the energy we produce will be used for computing, just for computing. So how do we address this challenge? Well, we need a new paradigm for how computing is done. So let's start by better understanding what we mean when we talk about computational power needs of AI. Here's a great way to imagine this. If we think back to 2007, not long ago, it was estimated that all of the computers in the world that year had the same computational power as one single human brain. Now, some of you may remember the abacus, right? Early computer. Think about the computational difference between the abacus and just one modern computer. That same difference can be found between the computer and the human brain. Okay? Here's the amazing part. The human brain runs on the same energy needs as one light bulb, even smaller. Now, that's about the same amount of energy it takes for one laptop. But again, the computational power of the brain is equivalent to 100 million laptops. So you can start seeing the enormous potential here when it comes to the problem of solving the energy challenge of computing. And that's exactly what we are working on at Yale. We're creating an interface between living tissue and computer technology, taking brain cells, growing them into 3D computing networks, also known as organoids. And essentially, we're exploring to what extent will the brain organoids be able to adapt, to memorize, to learn, and to compute. Recent advances in stem cell technology, bioengineering, machine learning, all make this science fiction research possible. So here you can see the activity of two connecting computing units, and you see the flashing. This is how they compute. And how do you build this? Well, here you can see a mini brain building itself. The living cells organize themselves into computing units very much like our brain does. We can actually control this very well to precisely pattern into computing machines, the cables and the computing units, pretty much the way we do with our computers today. So if we're successful, we can accomplish four things. First of all, we will have less energy consumption, less waste, less environmental heating. Second, we can create brain-like neural networks out of brain cells, and they can solve really hard problems. Third, we would have more secure information storage. And finally, very importantly, we hope that this will have a huge impact on the economy because it can create thousands of new jobs. So at Yale, we believe creativity is key to innovation, regardless of the discipline. Creativity can only help us find new innovative solutions to problems like computational power and sustainability. Solving these challenges will allow us to continue to drive the creative economy forward by expanding our ability to use computing and AI, and we can do that while mitigating the dangerous effects on climate change. Thank you.